All right, I'm Dave Weddle. I'm with McClanahan Corporation, and I guess I'm here to talk about training on the Blendmaster mixers. They're also called Pugmill mixers, but pretty simple piece of equipment. Give you a little bit of background about myself so you can follow along. Everything I'm going to talk about is going to be in the first page of the instructions. Little information about myself. Again, I'm Dave Weddle with McClanahan Corporation. Work in the engineering department. Graduated in '95 with a mechanical engineering degree from Penn State. Pretty much everyone at our company goes to Penn State. We're only located about 40 miles from Penn State University, and we have a local campus which is about 5 miles away. I said I've worked for McClanahan for 11 years, all in the engineering department. Our engineering department consists of about 23 people.
Except during the football season?
Well, no, actually, football season, we're all there. It's hunting season, where
gotcha.
most of us are not there. So
All
if you call pretty much the second week of November, company's empty.
All right.
There's more people, I think, missing for hunting season than there is Christmas vacation.
Gotcha.
In our engineering department, what we do a bunch of different things. We're just not the engineers. We do the equipment design. We do the CAD drawings. I've also done CNC programming and do equipment inspections, and we also come out on field service. We have some people from our shop who do field service, but the majority of field service is done by engineers. Little history on the company, and there's some information in the folders. It'll tell a little bit about it, but there's also a handout, the history of the company. We've been in business since 1835. We're one of the oldest family-owned businesses in the country. Started out as a foundry. We were a foundry for about 60 years before we started actually manufacturing our own equipment. We started out making crushers, and we went to log washer, which is very similar to the Pugmill mixers that you have. We're in our 6th generation of McClanahan. We actually have the 7th generation, was just born, so it's going to be quite a few years before she joins the company. But we're actually, I think, the oldest family-owned foundry in the country right now that's still operating in continuous operation. We're located about 100 miles east of Pittsburgh. So it's a little bit of a distance to get down here if you have any problems, but just a phone call away. We make, as I mentioned, the Pugmills. We make crushing equipment. We're into agriculture. We do screening of waste, animal waste. For one of the biggest things, we're an innovator in separating for sand from manure in the dairy industry. That's really big for the reclamation of sand in a lot of the huge dairy farms. They use the sand bedding for the cattle, and we use a machine in a way similar to what you have, but kind of injects some air involved, and it floats out the solids, and the sand comes out cleaner after processing than the original sand used for the dairy cows. The machine that we're talking about is a Blendmaster mixer. You have 2 of them. There's a brochure in here that it's for Pugmill mixers, which the definition of Pugmill is our larger heavy-duty industrial unit. You actually have on the back, which is a medium-duty Pugmill, which is also called a Blendmaster. And primarily it's used to either wet dry materials down for ease of conveying, or as in what you're going to be using for is to mix sewage sludge. Mix it with wood chips, rubber, and create a homogeneous mixture. The application that we're using for here is green waste sewage sludge with the wood chips. And the feed size is a maximum of 2-inch with an occasional less than 1% 6-inch lump involved. And the capacity that these machines are each quoted to do are 225 tons an hour. This machine is the largest that we've built. In the past, our largest machine has been a 44-inch diameter shaft. These are 54-inch diameter shafts, so it's quite a large piece of equipment to have. Each shaft is run by a 75 horsepower, 1800 RPM, 460 volt motor, and the shafts are turning at 45 RPM once run through the gearbox. If you pull out the drawings in the back of the folder, you'll see P22D38. And go over some of the main components. These machines are very simple. There's not much to them. The main component, obviously, is your washer or mixer box. That's your outside. It's made out of 5/16 inch steel plate. You have 2 shafts inside. The shafts at one end have a flight, which is a continuous spiral of steel, and also welded to it are a series of paddle bases. The flight is used with some bolt-on white iron shoes. What the shoes and the flight do, it gets the material moving from where you're introducing the feed at the feed opening. It'll actually get the material moving faster and push it up to the paddles, whereas the paddles' primary job is to beat the material and mix it together. At the discharge end, you'll see it's a Dodge TXT 915 reducer, the motor, your drive. At each end, there is a flanged gudgeon which extends through the box, and it has SKF 528 pillow block bearings with a set of shaft seals that go onto the box to keep material from spilling out of the box. Those are pretty much the main components. There's lids up on top. The lids are set up with interlocking switches, so when you open the lid, if the machine is running, it'll shut the machine down. You can keep those open. It may help you kind of follow. The operation of the machine is very simple. The inspection, and the first thing we'll talk about is the inspection and test run that we do. These machines were fully tested at McClanahan Corporation before you receive them, so there really shouldn't be any issues with them. The only thing that we do not do is we do not hook the motors up. We have our own test stand motors that we hook up, but all the drive and everything has been tested. All the bearings, everything's been run for at least an hour. At our company, we run them at full speed to make sure there's no issues with them. We check the welds, all the fits. We check the shaft trueness. We take a dial indicator at each end. We make sure the shafts are straightened to within 10 thousandths of an inch. Anything outside of that we feel is a little excessive. Shaft will need straightened to pull it in for the bearings. We check all the drive components to make sure the belts are tightened. Check the oil lubrication of the bearings, the gearbox, paint it, and like I said, we check the safety interlock switches as well to make sure that they're in operating condition. I went out this morning, checked operation. I went out with Mike. Everything seems to be fine, but I'll go over the pre-operation. This is what we check for when we come out into the field. If you look, this is kind of a condensed copy of our operations manual inside. It describes a little bit of the installation, the electrical, the initial startup, test run, break-in period, and then the pre-operational checklist, which is kind of what I'll go over. What you want to check for is you want to check to see that the machines are bolted down substantially. You know, all the fasteners are tightened. That the structure will handle the job. You want to check your oil levels in your gearbox. The oil levels were full when they left the company, so they should be fine. But there's an elbow, a 90-degree street elbow on the reducers with a tag underneath that says oil level. You can take the plug out of the elbow, look inside. Should be able to see the oil inside. The grease, you want to grease the bearings and the seals. Make sure before startup that everything's well lubricated. You want to make sure the rotation of the shafts are the proper rotation. Standing at the drive end, the material, you want the shafts to rotate up in the middle. It'll pull the material up and beat the material. You don't want it pushing it down towards the bottom of the box. I want to check the safety interlock switches, make sure that they work, which we checked them this morning. As soon as we lifted the lids, the motors shut down. But as soon as the lids go back closed, the motors will start back up. So, but they have to be, you know, down the whole way. And you want to make sure all the guarding is on the machine. At the discharge end, there are the two large drive guards that are covering up all the drive components, the reducer, the V-belts, the shivs. At the feed end, there are two expanded metal dog houses over top of the bearings. You want to keep those on there. You don't want the chances of getting in there and injuring yourself are slim, but still want to keep the guards on the machine. Are there any questions as far as pre-operation or anything? Okay. Standard operating procedure. First thing foremost is safety. You want to make sure no one's working on the machine, no one's doing anything to the machine during startup, and that's key. It's not a machine that you want to be inside. Bad things will happen. It's extremely dangerous piece of equipment. You want to sure all your guards are in place, all top covers are closed, and that no one is around the equipment. The startup's controlled by your startup controls. There's no start-stop button at the equipment. I'm not sure if it's controlled by a VFD or not. It is VFD. Okay. I mean, typically, you know, they turn on, turn off. You can't really do much adjusting. With a VFD, you could maybe do a little fine-tuning as far as changing some speeds up a little bit without changing the drive components. What you want to do, you want to start the box up empty, always. It doesn't have to be washed out empty, but you want as little material in the box as possible when you're starting this machine up. You know, the less load you have to put the motor under, the better off you are. It really should start up with the box loaded, but it's just better to have an empty box. And then as the machine's running, you want to add the feed material at a consistent rate. You don't want to really be dumping it. You know, it'll do 225 tons an hour, but you really don't want to be putting 225 tons in the first half an hour and 0 in the second half. It's not going to handle it. For a shutdown, just a repeat process. You want to shut your feed off to the mixer. Let the machine run out as much material as it can. That helps you in startup the next time. Start up. And if you're doing any extended shutdowns, for a few months, what you want to do then is you definitely want to wash the box out, get it as clean as you can. You want to fill your reducer up to 95% of the reducer level, the oil level. And you want to rotate the shafts once a week just to keep grease going to the bearings, and it'll just help out in the long run. As far as maintenance goes, it's pretty low maintenance. There's really not a lot of parts on one of these pieces of equipment, and for the duty that it's built for your application, it's really a pretty simple application out there. You would just want to lubricate the bearings and seals, and that's the main maintenance on this machine. You want to keep your oil level in the gearbox to the proper level. You want to check occasionally to see if you're getting any water condensation in the gearbox, but it's a sealed unit. You really shouldn't be getting condensation inside.
Is there tips on these on the paddles, or I forget? There's something you bolt on, right?
There's a paddle base that's welded to the shaft, and then you have a bolt-on paddle, which that's what the wear.
So do we hard face those, or we just let them wear out?
They're a hardened material,
Okay.
so they should last.
What did you call that when you first mentioned it? So the Flight has a bolt-on white.
The Flight has a bolt-on white iron shoe. If you look at the drawing, if you can kind of see them, there's a.
We can replace those.
You can replace the shoe. You can't replace the Flight. I mean, you can, but that's a little more serious work.
You'd
but
only have to do that if you let the shoe go, right?
Right. Yeah. If you let the shoe go and wear the whole top off of the shoe, it'll get to the Flight. Or if you get something inside that could bend a Flight.
Gotcha.
But for the most part,
So what's the life of those shoes in our application, do you suspect?
I would think a few years, definitely. We have similar shoes that we use in what we call our log washer, which is doing aggregate, which is a lot heavier duty application. I mean, you get 1 or 2 years out of those shoes. So I mean, they could last quite a few years. But you'll start to see the leading edge of the paddles will get wore down. It'll get kind of rounded off. So you can, at the time, you can flip the paddle the opposite way, and it'll give you a little more life out of the paddle.
You don't recommend hard facing that?
No, because what it'll do, it'll wear off the top of the paddle. I mean, there'll be nothing there to. I mean, you could try building it back up, but they're pretty simple. They're just a rectangular piece of.
The edge of the paddle, not the face of the paddle.
Yeah.
That's the way.
Right. I'm just thinking similar applications with windrow turners and stuff. You
Yeah.
just stick a bead on there every couple of months or something. You get, but I don't know if it's worth it. Probably
Yeah.
not.
Probably not. What you'll get, I'll draw it. Basically, your paddle looks like this, where it bolts to the paddle base, and it'll start wearing. It'll wear off. It'll just keep wearing down, and if you're looking at the end view of the paddle, it starts out like this, but it'll wear off kind of that way. It'll round the corners off.
And when you replace these, do you have to do all or nothing, or is there a balance issue?
There are 4, or I think maybe 5. There are 5 in a rotation. You'd probably be best off doing 5 at a time rather than an individual, or you want to stagger what you're doing to try and balance out. Would be best if you're doing a replacement.
Now, is the wear going to be more intense at the feed end rather than the discharge end? So it's going to be less as it gets toward the discharge?
It should be fairly consistent the whole way through. You may see a little bit more at the feed end, but it should be fairly consistent. Because what you're going to do is you're going to convey the whole bed of material up. Like I said, your Flight digs the material kind of to get it started from the feed end, But then when you get to the paddles, then you're just feeding from one to the next. So you should get a pretty even wear the whole way up the shaft.
Any questions? Worst case scenario, we get a rock going through there, pretty good sized one.
Mm-hmm.
Will it snap the paddle or?
No.
jam it?
No, it shouldn't. I mean, I don't know how big a rock that you're talking about, but chances are it's going to break the rock, or it'll move the rock. I mean, I don't know if you jam this machine.
I've had one where the rock gets underneath the paddle,
Mhm.
the base of it, and just locks it up.
Yeah, I don't know. It's a pretty big motor, turning these. It probably would break the rock. I mean, the shafts on these are pretty substantial, so I doubt you do any damage to the shaft or the paddle. Now, at the flight's more susceptible than what the paddles are. It's being continuous, and you may bend the flight, but it'll still stay continuous. It may be kind of an odd shape. You may have to heat it up, beat it kind of back into shape, but it should hold up. I don't think you'd have really. There's a pretty good distance between the bottom of the paddle and the box itself. So you'd probably look at least a 4 or 5 inch rock would have to get in there to, actually the machine to even notice that it's in there.
Got a question here. Based on what you just said, then the paddles, what's the clearance between the paddles and the trough wall?
I believe, well, it's actually the bottom. I think the outside's a little bit more than what the bottom is.
More clearance or less?
I think there's a little more clearance on the outside wall, but I believe at the bottom it's either 2.5 or 3 inches.
So there's always that 3-inch area that's being skinned over, it's not really being moved on.
Right. Kind of what you're doing, you're building a bed of material, and you're sliding against the bed of material rather than sliding against the bottom of the box. So you should really not have much wear inside the box itself.
So once it loads up, it'll be a little more effective than when you initially started.
Right. Yeah, it'll take a little bit for it to build. And it'll build it. The box itself is rectangular, so in the corners it'll build up the bed of material, and it'll actually be curved, and then it'll start moving the material. So it may take a little while once you start feeding it for it to build the bed up. Talked about the paddles and shoes, the V-belt drive. V-belt drive should last quite some time. You want to check for your belt tightness after you run a couple of days. Initial startup, you want to make sure that the belts are still tight, that they're not dried in any way, and make sure they're tracking straight. I mean, they should, but if they're starting to wear on the edges, you may have to adjust the shivs to get them aligned. As far as maintenance, that's about it. Question?
The paddles, they're bolted on?
The paddles are bolted on, yes.
Specifications is what they should be torqued to?
No, we just run an impact on them. We typically run, though, if you'll look at them, we run one bolt one way, one bolt the other way, and then we double nut them. Just follow the example of what's on the other ones. But we typically just put the impact on them. As far as troubleshooting, if you look in we'll call it the manual, there's a troubleshooting section. It's on page 6 in the maintenance section. There's really not a lot to go wrong with these machines. You can follow with me. If the machine doesn't start, the first thing checks your electrical, that there's electrical malfunction, or you have an oversized or hardened, the material is hardened around the shaft as far as it's sitting for quite some time, and it's too much pull on the motor to get things started. If the motors are operating, but the paddle shafts aren't turning. You want to check your drive components, make sure your belts are fine. There's not a key broken on your motor or your reducer. There could be reducer failure, or it could have paddle shaft failure, which that's pretty catastrophic if you have a paddle shaft failure. Bearings are too hot. You want to check, make sure that they've got lubrication, or you have to replace your bearing. You get a bad bearing. I said these are pretty simple. On a lot of our other designs, we have a flanged bearing that mounts to the box. These are a standard off-the-shelf pillow block bearing, split pillow block to replace the bearings. Not very difficult. If you have a pulley or shiv that stalls, then your V-belts are too loose. You'll have to tighten up your V-belts. To tighten up the V-belts on this unit, on your drawing, if you look, the motor is sitting on top of a base plate. Base plate is attached to the box with 4 pieces of all thread. Just have to loosen the nuts above the plate, and then tighten the bottom ones up to tighten your the tension in the belts. And if the material's not adequately mixed, you just want to check your feed ratio and how the material is introduced into the box. And as far as troubleshooting, that's all there is. List of spare parts. If you turn the page, actually 2 pages back from the troubleshooting guide, there's a list of the spare parts. What we recommend to have on site is a set of bearings, or actually for your 2 sets of bearings and 2 spare sets of V-belts. They're pretty much the only thing that day-to-day activity is going to cause you to shut down. If a paddle's worn, if the paddles, the shoes are worn, that's something you can live with for a little while. You don't need right away. That's something you'll notice. You'll at least have some advanced warning. If you're doing routine inspections, you'll start to see those wearing. That's about it. Field service, if you have any problems with the machine, I can come out. We have quite a few other engineers who come out to work on it. We have a dozen or so people in our shop who are qualified to come out, work on the equipment. We probably couldn't be there the same day, but the next day, if it's an emergency, someone could be out.
So is there a local rep around here that we could call on?
I don't know. There is a local rep. I know California Screen and Conveyor is our rep for most of the equipment in this area.
Is that in any of this information, their contact information?
No, it's not listed in here, but that's not an issue.
Okay.
I know we were kind of changing around our rep as of late.
Can you make a note to maybe pass that information along?
Sure.
Because we're kind of getting to know the local reps of all this different type of equipment, so we have a resource available locally.
Sure.
How thick are the shafts? What's the steel on that?
Let me check. Offhand, I think they're
Just roughly.
double XS pipe. I think I have the information in here somewhere. It's schedule 100, 16-inch diameter schedule 100. What that thickness is, I'm really not sure.
Okay.
I believe that may be 5/8.
Okay.
Schedule 100.
Any questions? Okay.
How often do you run into a bent shaft scenario? See that in the diagram there?
Yeah, it's very rare. You typically don't see that too often. Like I said, unless you get something extremely large in there that it comes down and hits, that it can't fracture. And if it's like I said, a rock, I mean, if it's a real hard rock that it can't break, you may raise it a little bit.
I would almost think it's gonna push the side of that box out in 5/16.
No, he said 5/8.
5/16 on the box.
Yeah, the box is 5/16. Yeah.
You're
trying to push it 5/8 times 2 sideways.
Yeah,
There's no liner in that box, right? It's just,
No.
it's steel then?
it just.
So
just
we got
steel.
a wear issue there we'd have to keep an eye on probably.
Not really.
No, because there's no interference, there's no contact.
Corrosion would be the biggest issue.
There's no it wouldn't be dragging material along the.
There's at least 2 inches of clearance, it's gonna build up like a dead zone.
Oh, okay.
Right. That's roughly what it'll do is it'll build a bed of material. It'll build kind of a bed of material, kind of like that in the box. So this will always stay. So what you're doing is you're just running on top of material. You don't have any direct drag down on the bottom of the box. Are there any questions?
That white iron, is there another name for it?
The shoe? No, it's just white iron. That's
Would it be the same hardness as manganese?
offhand I don't know. I know what the paddles are. They're a hard ox material, which they'd be much harder than the manganese. But it's probably comparable to manganese, the white iron.
I guess we're good.
Anything?
All right, thank you.
Does anyone want to go out to the machine, go over anything at the machine?
Well, I certainly don't think that hurt. I think Mike might have an issue with that today.